today we are going to look at the Unit 10 review sheet, exponential functions. So this first page deals with graphing. Depending on your teacher, you may or may not have done this slightly differently. In my class, I had my kids pull out the parent function, which is 2 to the x, and build a table of values for the original function. So if my parent function is 2 to the x, I picked -1, 0, and 1. So I get 0.5, 1, and 2. Then I used this table to make all the transformations that are being given in this equation. So the x plus 2 tells me to move everything to the left 2, and the plus 1 is telling me to move everything up 1. So moving everything to the left 2 affects the x values. Remember that we say that the x changes always do the opposite of what we expect. They lie. So instead of adding 2 to all of my x's, I'm actually going to subtract 2 from all of my x's. So -1 minus 2 gives me a -3, 0 minus 2, and 1 minus 2. Now this plus 1 changes my y values. So I'm going to take my original y values and I'm going to add 1 to all of them. We know that when we have a shift up or down, that in turn shifts our asymptote up or down. So since I moved up 1, my asymptote moved up 1. Now I'm going to plot the points that I was given. So 1, 2, 3, 1.5. -2, 2, and -1, 3. So there is my graph. If I want to determine if this is growth or decay, I read my graph from left to right. If it is moving away from my asymptote, it is growth. Okay? Alright, so on this next one, I have 2 times 1/3 to the x minus 2 minus 4. So this 2 is a stretch. The -2 in top moves it to the right 2, and -4 moves it down. Again, I had my kids pull out the parent function, which is 1/3 to the x, and we made our own little table, -1, 0, and 1. Okay, then I filled in my values. Now I'm going to go through piece by piece and make the transformations. So moving it to the right 2 is going to change my x's, and I'm actually going to add 2 to all of my x's. So -1 plus 2 gives me 1, 0 plus 2, and 1 plus 2. Now I have 2 changes that are occurring to my y's. I have to do them in the correct order. So think about PEMDAS. Would I multiply before I subtracted? Yes. So I'm going to stretch all these by 2 and then subtract 4. So 3 times 2 gives me 6, minus 4 gives me 2. 1 times 2 gives me 2, minus 4 gives me a -2. 0.33 times 2 and then minus 4 is going to give me -3.34. Remember, if I have a shift up or down, it also shifts my asymptote. So now my asymptote is at -4. Okay, and then I'm going to plot my points. So at 1, it's at 2. At 2, it's at -2. And at 3, it's at -3.34. Okay. If I read my graph from left to right, if it is moving towards my asymptote, that is decay. Alright. Alright, number 3 is looking at e to the x. So my parent function of e to the x. So I have e to the -1 gives me 0.37, 1, and then 2.72. Okay. This 1/2 is a shrink and the minus 3 is going to move it down 3. So my x's are not going to change at all on this one, but my y's are going to be multiplied by a half and then moved down 3. So I'm going to multiply by 1/2 and then subtract 3 on those y's to get my new table of values. So the x's aren't changing, but my y's, so 0.37 times a half, and then subtract 3, I get negative 2.815. 1 times a half, and then minus 3 gives me a negative 2.5. 2.72 times a half minus 3 gives me negative 1.64. Okay. Okay, so again, when we have an up or down shift, it moves my asymptote up or down. So now it's at negative 3. And I'm going to plot my points. So at negative 1, it's at negative 2.8. At 0, it's at 2.5. And 1, negative 1.64. If, as I read my graph from left to right, it's moving away from the asymptote, growth. Okay. So I will come back to number 4 after we've gone through the review. 5 and 6, you're given the graph, and you are asked to identify the horizontal asymptote and the domain and range. So if I look at this one, my horizontal asymptote is at negative 1, negative 2, negative 3, negative 4. So y equals negative 4. Remember that my domain for all exponential is negative infinity to infinity. I can use any x that I want. Range is dependent on where your asymptote has been moved. So on this one, it's going to start at negative 4 and go to infinity. We'll come back to number 6. Go ahead and flip it over. On 7 and 8, we are determining based off of just the equation whether it is exponential growth or decay. Remember, we need to look at the base. So the base is the number that is being raised to the power. So in this case, it's 0.71. If my base is between 0 and 1, it is decay. If my b is greater than 1, it is growth. If you're not sure, you can always graph this in your calculator and see if, as you read it from left to right, if it's moving away from the asymptote or towards the asymptote to answer that question. On 8, your b is 1.41, so it's greater than 1 this time, so we have growth. Okay. On number 9, we are going to write the equation of an exponential function given the parent function and then different transformations that are being made. So our parent function is y equals 5 to the x. I'm going to go 6 units to the right, 4 units up, and a reflection across the x-axis. So a reflection across the x-axis is going to be a negative in the front. 6 units to the right means I'm going to move to the right. So if I do that, it lies, so I'm going to say minus 6. And then 4 units up, plus 4 at the end. Okay. All right, on number 10, we are given the equation that models the number of cell phones in use in the United States. We're told that the number can be approximated by 7.12 times 1.3 to the t, where t is the number of years after 1990. So we want to know, what is the growth rate? So remember that when it is growing, inside my parentheses, it's 1 plus r raised to the t. Well, if I have 1 plus 3, 1.3, then what is r? I take the 1.3 and I subtract 1. So r is 0.3, but if I'm going to change that to a percent, it's 30%, because I'm going to move my decimal to the right 2 times. So I want to estimate the number of cell phones in use in 2010. Remember, we're looking at the number of years after 1990. So from 1990 to 2010, how many years have gone by? That's 20. So I'm going to plug 20 in for t. Remember, I can plug that directly into my calculator. And I'm going to get 1,353.15. And remember, that is in million of cell phones. All right. Number 11, at the peak of Cabbage Patch doll sales, one sales representative sold 10,000 of the dolls in 1 month. So that 10,000 is going to be your initial amount. It says each month after that, the rep sold about 30% fewer. That's R, and we're looking at fewer, which means we're looking at decay. So if I want to write the exponential function that models this situation, remember I'm filling in this equation. So my initial amount was the 10,000. It says 30% fewer, but when I plug that in, I need to go ahead and change that to a decimal, and then raise to the t. Right, on B, we're trying to figure out how many dolls the rep sold in the 8th month. So we're going to go ahead and plug in 8 for t. And remember, I can plug this directly into my calculator, and I get 576.48 dolls. Okay? All right, 12. Emily purchased a painting in 2000 for $10,000. Experts expect that its value will increase by 15% per year. So 10,000, remember, is your initial, and the 15% is your R, and it's increasing. So if it's increasing, we're looking at 1 plus R to the t. So if we want to write the equation that models this situation, initial amount was 10,000. It's going to increase by 15% over time. Okay. What is the value of the painting today in 2019? Well, how many years have gone by since 2000? 19, so I'm going to go ahead and plug in 19. Okay, straight into your calculator. So the painting would be worth $142,317.72. Okay. All right, let's go ahead and look at the next page. So on 13, we're looking at exponential regression. So this goes back to what we did on that very first day where we did the penny, or in my class, the M&M lab. So we are going to have to plug these values into our calculator. So on my calculator, I'm going to go to Stat, Edit. In L1, I'm going to put the months. Okay. In L2, I'm going to go ahead and put that total downloads. Once I have all of my numbers in here, I'm going to go ahead and go to Stat, Calc, and I'm looking for exponential regression. So it is 0. So I hit Enter. Then I go down to Calculate. And this is giving me my equation. It's telling me that it comes in the form of y equals a times b to the x. And a is 0.209, and then times 1.124 to the x. I could have made it 2.1 because if I went ahead and rounded the 9, then it would have been 2.1. Okay, so either one is okay. All right, on 14, it says Eric has $2,000 to put in savings for 4 years. 3 banks have offered different investment plans. Okay, so Bank A is going to do 3% annual. B is going to do 2.875 continuous. And C is going to do 3.125 continuous. All right? So we need to decide which one is going to give you the best return on your money. So for annual, we're going to take what we originally invested, the percent we're going to earn, and if I'm compounding annually, then N is just 1. And remember, he's leaving it in there for 4 years. So I can plug this directly into my calculator. So 2,000, 1 plus, and if I want my fraction in there, alpha y equals to 0.03 divided by 1. And then I'm going to raise that to the 4th. So at the end of the 4 years here, you would have $2,251.02. Okay. Now, when we say continuously, we are using a different equation. Remember that continuous takes me to the PERT equation. So 2,000 e to the r times t. Okay, so again, I can put it directly in my calculator, 2,000 e to the 0.02875 times 4. And I would have $2,243.75. So between A and B, I already know that A is a better choice, but now I need to check for C. So again, C is saying continuous, so I'm using PERT, and this time it's 3.125 for the 4 years. And let's see what we get. So $2,266.30. So C is going to earn him the most money over those 4 years. Okay. On 15, we are just evaluating a power of E to 3 decimal places, so I'm just going to plug it directly into my calculator. I want a fraction, so alpha y equals enter, and then I have E to the negative 3.19, and I'm going to divide that by 0.015. So I want to make sure that what's inside my calculator looks exactly like what I have on my page, and then hit enter. So to 3 decimal places, 745. So 2.745. Okay. Number 16, we have somebody depositing money into a bank that pays 3.25% interest compounded quarterly. So remember that quarterly means that N is equal to 4, 3.25 is R, and 800 is your initial. You're going to leave it in there for 10 years, so that is T. So I'm going to go ahead and set up my equation. Actually, we have that as A. Sorry. 1 plus 0.0325, and if we're compounding quarterly, then N is 4, and then 4 times 10. Again, directly into your calculator, so 800, 1 plus, let's go ahead and get my fraction, so 0.0325, and divide that by 4, and then raise it to the 4 times 10. I want this to look exactly like it does on my paper, parentheses and all, and then hit enter. So after 10 years, you'll have $1,105.77 in an account. Okay. We'll come back to 17 after we finish the review, but it's another problem exactly like number 16. The only difference is we're going to compound monthly, which makes N 12. All right, so we'll come back. On 18, you're given the equation. It says that a constant temperature, the atmospheric pressure in pascals, is given by the formula. P is equal to 101.3 times E to the negative 0.001 H, where H is the altitude in meters. So find the pressure at 200 meters. So I am just going to plug 200 in for H. Okay. Once I have that, I'm going to go ahead and plug it directly into my calculator. And I want to make sure that this looks exactly like what I have, and then hit enter. So 82.937. Okay, so that is the pressure. Oh, sorry. All right, let's flip it over. Last page, and then we will go back. All right, so 20. We want to look at what is the horizontal asymptote of the function y is equal to 2 times 0.3 to the x minus 1 minus 3. Remember, my horizontal asymptote only changes if I have a shift up or down. This minus 3 at the end is telling me that it's going to go down 3. So my horizontal asymptote is at negative 3. Okay. 22. Gasoline costs $2.99 per gallon. So this is going to be your initial. If the price per gallon increases an average of 7% per month, write a function that models this exponential growth. So this is my R, and it's increasing. So my equation is y equals a times 1 plus r raised to the t. So let's go ahead and plug in what we know. So it's $2.99 to start with, and we think it's going to increase by 7% each month. So there is my equation. All right, 23, write an exponential function when the following transformations are applied. So again, this is like one that we did earlier. This time our parent function is 3 to the x. We're going to go 2 units to the right, 4 units down, and has an initial value of 5. So our initial value is going to be the stretch, then 3 to the x. If I'm moving right 2, it's minus 2, and then down 4, minus 4. Okay. 24. Beth would like to have $1,200 after 5 years. So how much should she put into a bank account that pays 1.2% interest compounded annually? So this time we're actually looking for the initial amount. We have time, we have the interest rate, we know how it's compounded, and we know what we want. So 1,200 is equal to 1 plus 0.012 over 1 raised to the 1 times 5. So I'm compounding annually, which means once a year, so n is just 1. I want to know what I would have to start with. Well, we're going to do just this portion in our calculator. So we are going to do 1 plus 0.012 divided by 1, raised to the 5th. So I get 1,200 equals p times 1.061. Now if I'm trying to get p by itself, I'm going to divide both sides by 1.061. So 1,200 divided by 1.061. So p is equal to $1,131.01. So that is how much I should start with if I want 1,200 in there. All right. Similar problem, so Jack would like to save $4,000 in 5 years in order to buy a Jeep. So how much would he put into an account that pays 3.7 annual interest compounded continuously? So 4,000 is what you want, and 5 years is time, 3.7 is my R, but this time I'm compounding continuously. So remember I use a different equation, I use PERT. So 4,000 equals P times E to the RT. So I want to be able to find P. So again, I'm just going to do this portion in my calculator. So I have E to the 0.037 times 5. So 4,000 equals P times 1.203. And now to get P by itself, I'm going to divide both sides. So 4,000 divided by 1.203. So $3,325.02. is what he would need to start if he needs that $4,000. Okay? All right, that is one of every type of problem. So now I'm going to go ahead and go back and finish working through the rest of the review. So on the front, we need to finish up number 4. So my parent function here is 10 to the x. So I'm going to start with my little parent function chart. So 0.1, 1, and 10. And now I'm going to look at my transformations. This 3 is a stretch, and the 1 moves it up. So no changes are being made to my x's this time. But I'm stretching them by 3 and then adding 1. So I have to take my y's, so 0.1 times 3 plus 1, 1 times 3 plus 1, 10 times 3 plus 1. So that last point I'm not really going to get on my graph. My horizontal asymptote is now at 1, because I shifted everything up 1. And now I'm going to graph, so negative 1, 0, 4, and my last one's going to go off. If I read my graph from left to right, it is moving away, which makes it growth. All right, on number 6, again, you're given the graph and you're asked to identify domain, range, and horizontal asymptote. So my horizontal asymptote this time is at y equals a positive 3. Domain is negative infinity to infinity. This time range is going to go from my asymptote up, so 3 to infinity. We finished all of the ones on the back of that page, so if we go to the 3rd page, we need to go back and finish number 17. So depositing $1,000 into a bank account that pays 4% interest compounded monthly. So my $1,000 is my initial. My 4% is my R. It's compounded monthly, so N is 12, and 3 is T. So let's go ahead and set up our equation. So 1,000, 1 plus 0.04, and we're compounding monthly, so N is going to be 12, raised to the 12 times 3. So let's go ahead and plug that into our calculator. So I have 1,000, 1 plus, get my fraction, 0.04 divided by 12, raised to the 12 times 3. Make sure that they look exactly the same before you hit enter. So after those 3 years, you have $1,127.27. Okay. Alright. The only one we have left on the back is number 19. So we are given the equation P is equal to 70 times E to the 0.22T. We're looking at a population of bacteria after so much time has passed. So we want to know what is the population after 6 hours. So we are going to evaluate our equation at 6. Okay, so let's go ahead and plug it directly in. So 70 E to the 0.22 times 6, and then hit enter. So 262.039. Okay. All right, so that is all of Unit 10 review. Make sure you study.